You can do it if you believe you can. Hi, everyone. Let's take a look at the following grade 11 math major topics. Number one, polynomials. Number two, factoring. Number three and four, simplifying rational expressions, multiplying, dividing, adding, and subtracting. Now, before we begin, if you want to fast forward to any upcoming examples, use the hyperlink in the description below. But we will begin with example number one. Expand and simplify. Step one. Draw the arrows. 6 times x, 6 times negative y. Likewise, draw these arrows. Negative 2 times 2x, negative 2 times 7y. So notice I said negative 2. So I would like to invite you to think about negative 2 and not positive 2, even though both methods will work. We're going to see why this one's a little bit more effective in terms of getting full marks on a quiz or on a test or on the final exam. Likewise, when you think about this negative 1, draw the arrows just like that, and I'll circle negative 1. So in the first step here, when I think about 6 times x, that's going to be 6x. 6 times negative y, negative 6y. Negative 2 times 2x is negative 4x. Negative 2 times 7y is going to be negative 14y. Negative 1 times 3x is negative 3x. And negative 1 times negative 2y is going to be positive 2y. Here comes step number 2. Collect like terms. So if you like, you can grab different colors. I'm using yellow here to collect all the terms with the variable x. I'm going to grab a different color, green, which represents all the terms with y. So now, when I think about 6x minus 4x minus 3x, 6 minus 4 is going to be 2, 2 minus 3 is going to be negative 1. I can say negative 1x, I can write negative x, either one is fine. Likewise, when I think about negative 6y minus 14y plus 2y, negative 6 minus 14 is negative 20, plus 2 is going to be negative 18y, just like that. Example 1b. Again, if I look at x plus 3 times x squared plus 2x plus 4, the first step is to draw the arrows. The arrows is a wonderful way to keep track of all your work in order to maximize your outcome. So again, the first step is to look at x times x squared, which is x to the power 3, x times 2x, which is 2x squared, x times 4, that's going to be 4x. If I look at the bottom arrows, and I'll write that in the second row due to space, 3 times x squared is going to be plus 3x squared. 3 times 2x is going to be 6x. 3 times 4, that's going to be 12. Again, for your reference, I'll grab a different color. We're going to collect like terms. So all the terms with x squared, I'll circle in one color. All the terms with x, I'll circle in a different color. Again, notice x cubed, it's on its own. I can cross it out to stay organized. 2 plus 3 is going to be 5, so it's going to be 5x squared in this case. 4 plus 6 is going to be 10, which is 10x. Copy the plus 12, just like that. So again, every step we're showing you is worth marks on the upcoming assessment of learning. Let's keep going. Example 2a, factor fully. X squared minus 6x minus 16. So again, this is also known as simple factoring. The first step is to go back and say x squared could be thought of as x times x. Step 2, think about the two numbers that will add up to negative 6, and they multiply to negative 16. So again, you can do a little bit of mental math. You can write it out on paper. But basically, when I think about the factors of 16, I'm thinking 16 and 1, 2 and 8, 4 and 4. And the only combination that can really give you a sum of negative 6 is 2 and 8. Now, mentally, you're thinking, is it going to be 8 minus 6? Is it going to be 2 minus 8? And in this case, it's going to be positive 2 minus 8. Now, I'm going to over-deliver, everybody. I'm not expecting you to do this. I'm inviting you to do this because if your goal is to get 100%, what I'm going to invite you is to double check with me here and now. The opposite of factoring is expanding. So if I expand x plus 2 times x minus 8, I will get the question back. If I don't get the question back, that means there's a mistake. I go back and I try again. Now, if you think about x times x, that's x squared. X times negative 8 is negative 8x. 2 times x is 2x. 2 times negative 8 is negative 16. Again, if I collect like terms, this is going to be x squared minus 6x minus 16, which should not be a surprise. This is exactly what we started with. So again, by double checking, hashtag, you have received 100% before even getting your assessment of learning back. So again, something I would like to invite you to think about if your goal is to get 100% of the time. Example 2b. If you look at 25u squared minus 15u minus 18, again, this is complex factoring. So there are many ways to do this. One method is called the crisscross, the box method, the bubble method. It all really mean the same thing, different names. And the way it works is you draw this box and you write down the factors of 25. So 25 and 1, 5 and 5. So that's the factor of the first number. You look at the factor of the last number, negative 18. And again, you're thinking, for example, 18 and 1. You might be thinking 2 and 9. You might be thinking 3 and 6, and so on. Now remember, your goal is to find a combination that will give you a sum of negative 15 and a product of negative 18. So for example, if I try 30 and 15, so notice what I'm doing. 5 times 6 is 30. 5 times 3 is 15. So 30 and 15, that could give you negative 15. And now you're thinking, is it 30 minus 15? Is it 15 minus 30? And I would say it should be positive 15 minus 30. And of course, in a different color, note negative 6 times 3 will give you negative 18. So I go back and I write down the following. 25u squared is going to be 5u times 5u. Now 5 is the multiplier of negative 6. So I'm going to put negative 6 there because you want to make sure you put it in the second bracket. Now by chance they both have 5u, so it doesn't really matter. Even if you wrote negative 6 here, it does make sense. But in general, remember, 5 times negative 6, you want to put it in separate brackets. And the positive 3 goes like that. Now again, I'm going to over deliver, right? This is only for those students who's thinking my goal is to get 100%. So how do we do this? We expand. So if I take 5u plus 3 and I multiply this by 5u minus 6, this is going to be 25u squared minus 30u plus 15u minus 18. Again, by collecting like terms, that's 25u squared minus 15u minus 18. Again, it should not be a surprise that this is the same as the original question, just like that. Example 2c. W squared minus 64. So this is also known as difference of squares. Now I'm going to add a baby step before we go straight to the answer. You really want to express this as something squared minus something else squared. So for example, w squared minus 8 squared. And of course, using difference of squares, that's w minus 8, w plus 8, just like that. Now, to be consistent, again, I am over-delivering. I am showing you how to get perfect. Double checking means you can expand this. So if you take w minus 8 times w plus 8, this would give you, again, w squared plus 8w minus 8w minus 64, which means if you look at the middle terms, that's going to be 0. And w squared minus 64 is exactly the question that we started with, which again should not be a surprise. Example 2d, a cubed minus 14a squared plus 49a. Step 1, common factor. Bring the a to the front. In the brackets, it's going to be a squared minus 7a plus 40, oops, one moment, I made a mistake here. It's a squared minus 14a plus 49. There we go. So again, step 1, common factoring. Now the second step is, if you kind of look at it carefully, it's really a perfect square. But if you didn't catch that, of course, you can still write it out separately. That's fine. So a squared is going to be a times a. Think about the factors of 49. That will give you a sum of negative 14. So I'm thinking 7 and 7. But remember, you're looking for negative 14. So I'm thinking negative 7 in both cases. This really equals to a times a minus 7 quantity square. Now, I'm not going to double check this, but if you like, you can pause the video, double check it, and you will get the question back as expected. We are making progress. Let's move on to example 3, where we're going to multiply and divide rational expressions, and we're going to state restrictions. Are you ready? Here we go. If you think about x squared plus 5x plus 6, the first step is you want to factor it in terms of x times x. That's going to be x squared. Again, think about two numbers that will multiply to 6, but they add up to 5. So 2 and 3 will add up to 5. 2 times 3 is going to be 6. So this first trinomial is factored. Likewise, if you look at the second part, x squared plus x minus 30, x squared means x times x. Negative 30, think about the factors. 30 and 1, 2 and 15, 3 and 10, 5 and 6. Think of the combination that will give you a sum of positive 1. So for example, 6 minus 5. Again, if you look at the denominator, x squared minus 6x plus 5, same idea. X times x is x squared. Now this one you got to be careful, right? If you think about the factors of 5, which can only really be 5 and 1, you're looking for a sum of negative 6. So be mindful, they're both going to be negative. Last but not least, x squared plus 9x plus 18. X squared means x times x. If you think about 18, I'm thinking about the factors that will give you a sum of positive 9. So for example, if I'm thinking 3 and 6, they add up to positive 9. Now be mindful here. Remember, you want to write down the restrictions. So before we start simplifying this, if you look at the denominators, you can see that x cannot be, in this first case, x cannot be 5. And likewise, in the second case, you can see x cannot be 1. Then the next one's negative 3 and negative 6. Now, if you write this in order, fantastic. If you don't put this in order, fantastic. It's really up to you mathematically. They're both equally good. I go back. I'm going to switch colors for your reference. Notice how you can cross out x plus 3 divided by x plus 3. Likewise, you can cross out x minus 5 divided by x minus 5. Last but not least, you can cross out x plus 6 divided by x plus 6, which effectively equals to 1. So again, the final answer is going to be x plus 2 divided by x minus 1, where x cannot be 5, 1, negative 3, and negative 6. Example 3b. Again, we're going to divide in this case, and we're starting with x squared minus xy minus 20y squared. So step 1, we're going to factor this, and you want to be mindful. Let me make sure I put an equal sign in the previous case. Yes, I did. Now, x squared means x and x times x. If I think about the factors of negative 20, that will give you a sum of negative 1. I'm thinking 4 and 5. Now, here's a common mistake. Don't forget, it's 20y squared, so you have to copy y in both cases. And to make a sum of negative 1, you're going to take negative 5, positive 4, just like that. Likewise, if I look at the denominator, x squared means x times x. If I think about 15, I'm thinking 3 and 5. Again, don't forget to attach a y. My goal is to find a sum of negative 8. So negative 3y, negative 5y will give you negative 8xy once you expand this. And of course, negative 3 times negative 5 is positive 15. Now, again, be mindful. You're effectively going to be multiplying by the reciprocal, right? So I'm still going to copy divide by now, or at this moment, but I'm going to be really multiplying by the reciprocal. So when you think about the restrictions, there's an additional step, and I'll talk about that in the following line. Again, x squared plus 2xy minus 8y squared, x times x, x squared. If I think about the factors of 8, that will give you a sum of positive 2. It's going to be 4y, 2y, but remember, we want positive 2, so it should be 4 minus 2. If you look at the denominator, x squared is basically x times x. If I think about the factors of 6, such that it will give a sum of negative 1, then it should be positive 2 minus 3, just like that. Now, before I keep going, you want to be mindful. If you think about the restrictions, and I'll put this in a different color for you, right? You have to look at the original denominator. And you're also going to look at the numerator in a moment. So there are multiple parts here. And the part you want to focus on right now is the original denominator, because once you multiply by the reciprocal, it's very easy to forget that. So again, x plus 2y cannot be 0. This means x cannot be negative 2y. That's this first bracket right there. Likewise, and I'll put a box around this. Likewise, if I look at x minus 3y, which cannot be 0, then this signals to you that x cannot be 3y. So again, we put a check mark to acknowledge we took care of those restrictions. Again, at this point, you can cross out x minus 5y divided by x minus 5y. But since you're going to cross it out, you might as well add those restrictions. So if x minus 5y cannot be 0, then remember x cannot be 5y. And of course, in the first bracket here, if you want to go slightly faster, you could. Notice how x cannot be 3y, right? And we kind of wrote this, and you're going to see how you don't have to write a choice at the end, because this will be crossed out in the next step, but you can just write the restriction once. So put a check mark just like that. Okay. Now there's some shortcuts, but if you want to really show the steps, it's going to be x plus 4y divided by x minus 3y. You're going to multiply this by x plus 2y times x minus 3y divided by x plus 4y times x minus 2y, just like that. So again, if you look at the denominator, there are two additional restrictions you want to pay attention to. So this is, again, what I made reference to. Don't forget here, right? And I'll put it up here for you. So x cannot be, in this case, negative 4y. I'll put a box around that. I'll put a check mark to acknowledge I've looked at that. And of course, x cannot be, this is the final restriction, x cannot be 2y. And again, put a check mark to acknowledge I took care of that restriction as well. So now I go back and I can cross the following terms. So x minus 3y, I can cross out. That's going to be basically 1. And I can cross out x plus 4y divided by x plus 4y. So here comes the final answer, which I'll put a box around. Here's the answer. So once you simplify everything, you're left with x plus 2y divided by x minus 2y, comma, which means you're going to state the restrictions. And remember, you don't have to restate, or you don't have to state the same restriction twice. So you could say, for example, negative 4y, which I'll put a check mark here, comma, 2y. I'll put a check mark here. There's negative 2y, so I can put that in the same line, plus or minus. There's 3y, which I'll put here. And last but not least, 5y, just like that. And that's how you solve example 3a, everyone. Example 4a, adding and subtracting rational expressions. So in the first case, you have 2 divided by x plus 1 plus 3 divided by x plus 2. So the first step is you want to find a common denominator. And to do that, you have to multiply each fraction by what is missing. So for example, in this case, if you think about the common denominator for x plus 1 and x plus 2, the answer is going to be the product. So I need to multiply the first fraction by the missing common denominator. So for example, there's a missing common denominator of x plus 2, which I'm going to multiply. Now, when you do that, by the way, you're effectively multiplying by 1. You don't change the value, but you are changing the form. Let me put this number back in for you. Now, likewise, in the second bracket, there's a missing x plus 1 divided by x plus 1. Again, you're really multiplying by 1. You don't change the value, but you are changing the form. And the most difficult part is over now, because, the common denominator is going to be x plus 1 times x plus 2. And when you expand this, again, you can draw the brackets, you can draw the arrows, this would give you 2x plus 4 plus 3x plus 3. And here comes the final answer. And we'll write down the restrictions as well in one box. If you collect like terms, 2x plus 3x is 5x. 4 plus 3 is going to be 7 divided by x plus 1 times x plus 2, where x cannot be, here comes a bit of mental math. Are you ready? X cannot be negative 1, x cannot be negative 2, just like that. Example 4b, again, we're subtracting in this case, and there's a little bit more in terms of the mechanical steps. So here we go. Step 1, we're going to look at 2z minus 1. We're going to copy that. But if I look at the denominator, 4z squared minus 25, that was kind of what we made reference to from before when we talked about factoring. Difference of squares. So for example, 2z minus 5, 2z plus 5 minus 2z plus 5. If you look at the second denominator, 4z squared minus 8z minus 5, we're going to factor this. And again, this is where you have to use the bubble method, box method, crisscross. Again, different names, same idea. If you look at the factors of 4, 4 and 1. You look at the factors of 4, 2 and 2. You look at the factors of 5, it's going to be 5 and 1. Now your goal, again, I'll use a different color for you, is do you want to make a sum of negative 8. So for example, if I'm thinking about 10 and 2, that can give you 8, but I'm looking for negative 8, so it has to be 2 minus 10. So again, I go back and I write down 4z squared is going to be 2z times 2z. 2 has to multiply with negative 5. The other one multiplies with positive 1. Again, it doesn't matter which bracket just because they both contain 2z, but in general, you want to be mindful. So now we can find the common denominator. And if you look at it, notice how in both brackets or both fractions, we have 2z minus 5. So we don't really need to create another one. You just copy that, and you're going to multiply by 2z plus 5, 2z plus 1. So this signals to you we need to multiply again, but the missing common denominator. In the first fraction, there's a missing common denominator of 2x or 2z plus 1 divided by 2z plus 1. In the second bracket, there's a missing common denominator of 2z plus 5 divided by 2z plus 5, which I'll put brackets. And now we can work it out. Now be very mindful here. This negative sign implies you should put a set of brackets around 2z plus 5. That's going to help you to get full marks. So again, if I look at 2z minus 1, 2z plus 1, this is going to be difference of squares. This is going to be 4z squared minus 1. So again, your polynomial skills should be fairly strong, right? And if I look at the next one, I put minus, put the brackets here, which is the bracket right there. This is a perfect square, 2z plus 5 times 2z plus 5. If you apply the formula, by the way, it's going to be 2z squared, which is really 4z squared, because you put that in brackets. 5 squared is going to be 25. 2 times 2z times 5 is going to be 20z, just like that. Again, we're going to write down the restrictions all in this final step at the bottom here. So maybe I'll put it right here. Hopefully I can write it in this box like this. So really stick with me. Watch the way I do this. You know, if I take out the brackets, by the way, what happens is all the signs inside will change. So this is negative 4. This is negative 20z. This is negative 25. So what that means is if you collect like terms, 4z squared minus 4z squared, that's going to be 0. You still have the negative 20z, and negative 1 minus 25 is negative 26, divided by the common denominator, which I can copy, 2z minus 5, 2z plus 5, 2z plus 1. Now again, if you've watched everything we've done up to this point, I sincerely hope you can find the restrictions with me. You got this, everybody. And if you need to go back to the first example, feel free. Hit the blue hyperlink in the description below. So in this case, z is going to be 5 divided by 2, or I should say z cannot be 5 divided by 2, plus or minus, and z cannot be negative 1 divided by 2. All right, example number 5. This is when we start multiplying, dividing, adding, and subtracting at the same time. Now, here's the tip of the day, everybody. Bad math. Very often, we have students who would start going left to right without thinking about the operators. For example, do we look at multiplying first, subtracting first? What do we do first? And the correct sequence is you always multiply and divide before you add or subtract. So step one is I'm focusing here, not because I'm going left to right, but because I multiply before I divide. That is kind of the key. So again, if you really look at it, I can cross out m plus 2 divided by m plus 2, which will give you m plus 3 divided by m plus 1, and I'm adding it to 5m divided by m plus 1. Now, in the same breath, I also recognize in that final line, m cannot be negative 2, right? That's one of the restrictions. And I might as well write down m cannot be negative 1. I go back, I need to find a common denominator, and I realize I do have a common denominator, so I can just keep going. So you can combine them and say m plus 3 plus 5m divided by m plus 1. Here comes the final answer. M plus 5m, 6m plus 3 divided by m plus 1, where m cannot be negative 2, negative 1. And that's it. That's how you do it. Great starter, great finisher. Example number 5b. Again, this is where we're dividing and subtracting in the same question right here. So again, the first step is you factor x squared plus 5x plus 6, which is going to be x plus 2, x plus 3. So notice I'm speeding up on you because you've practiced so many examples up to this part of the video. Likewise, if I look at the denominator, x squared minus 3x plus 2, that's going to be x times x, which is x squared. I think about the factors of 2, that will give you a sum of negative 3, which would be negative 2, negative 1. Now, I'm dividing, so I'm really multiplying by the reciprocal. And since I'm doing it like that, right off the bat, be mindful, right? At the end here, x cannot be 1, that's the original denominator. It cannot be negative 3, that's the new denominator. And of course, if you look at these two parts, x cannot be 2, and x cannot be 1, which we wrote down already. So that's going to be part of our final answer in a moment. Now, don't forget, you're still subtracting 6 divided by x plus 3. And we wrote the restriction for that as well. Now again, in a different color, for your reference, I can cross out x minus 1 divided by x minus 1. I can also cross out x plus 3 divided by x plus 3, which effectively is going to be 1. To find a common denominator, I need to multiply the second fraction by the missing common denominator, which is x minus 2 divided by itself. And in the first bracket, I'm going to erase this so I can create a bit of space for myself. This is going to be multiplied by x plus 3 divided by x plus 3. Let's put some brackets here, just like that. Now we have a common denominator, right? It's going to be x minus 2 times x plus 3. If I expand x plus 2 times x plus 3, again, x squared plus 5x plus 6. I'm demonstrating flow. This is kind of who you need to become. Now be very mindful in this step right here. It's negative 6 times x, negative 6x. Negative 6 times negative 2, that's positive 12. Are you ready? Here's the final answer. X squared, I copy. If I look at 5 minus 6, that's negative x. 6 plus 12 is going to be 18, divided by the common denominator. Again, writing the comma, meaning where x cannot be 1, negative 3 and 2. I hope this makes sense.